So now we're going to work through some of these unit conversion questions. Hopefully at this point you've had an opportunity to work through them. As I said, we won't necessarily go through all of them, but we will go through quite a few of them. And in that, and then I will post the answers to all of them on Blackboard. So as you can see, we're going to start out very, very simple with just a milliliters to liters conversion. Something like that is always going to be just a one-step question, and then we're going to gradually get more complicated. And in that regard, we're going to work our way up to a fairly complicated problem. So here in our first problem, we're just going from milliliters to liters, and we know that's a direct conversion. There's 1,000 milliliters in 1 liter, and so that's the only conversion factor that we need here. So 87.36 milliliters times our liters go on top. That way milliliters go on the bottom, and they can cancel. Again, milliliters cancel. And we should keep the 4 significant figures that we started with in our answer. We get 0.08736 liters. Remember, of course, that these first 2 zeros, being what we call leading zeros, are not significant, and that leaves us with the 4 significant figures that we started with. The next 2 parts of this question are very, very similar problems because they're both exclusively dealing with metric units, but they require us to do multiple conversions. Because it's fairly straightforward to go from nanometers to meters and meters to kilometers, but it's much less likely that we would know a conversion that would let us go directly from nanometers to kilometers. So the relationship between meters and nanometers, we know that 1 nanometer is 10 to the 9th meters. And as we've already used, we know 1 kilometer is 1,000 meters. So what we're going to do then is these 2 conversions will allow us to go stepwise from nanometers to meters and then meters to kilometers. So we start with our first number, our measured value, 4.85 times 10 to the 4th nanometers. We'll convert that to meters. Nanometers here go on the bottom, meters on top, and then we do a second conversion from meters to kilometers. Meters on the bottom, kilometers on top, and we find that our 4.85 times 10 to the 4th nanometers converts to 4.85 times 10 to the minus 8 kilometers. Now we're going to ask our question here. Does this answer make sense? And hopefully we come up with that yes, it does make sense. Because a nanometer is something that we know is very, very, very small. A kilometer is much larger. So when we're converting from nanometers to kilometers, we should end up with an answer, a number that's much, much smaller. All right, I'm going to skip ahead to part E, the milligrams per liter to pounds per gallon. So again, as we saw on one of our previous questions, we're going to need multiple steps here. And so I'm going to go now to a blank page so that we can work through this problem with plenty of room. So 8.2 milligrams per liter, and we're trying to convert to pounds per gallon. So for our mass unit, we can go from milligrams to grams, and then I'm going to go grams to kilograms, and then we can look up a conversion to go from kilograms to pounds. So that'll let us convert our mass. We're going to need to do 3 conversions there. Liters, we can look that one up, and we can find a direct conversion from liters to gallons. So that'll be our final conversion that we need. So 8.2 milligrams per liter. We're going to convert that first to grams. So 1 gram on top, 1,000 milligrams on the bottom. Go from there to kilograms. 1 kilogram is 1,000 grams. And then from kilograms to pounds. 2.21 pounds is equivalent to 1 kilogram. So as you can see again, milligrams cancels, grams cancel, and kilograms cancel, and we're left with pounds. Now we can do the same thing the other way. To convert our volume unit. But now we need liters on top so that liters can cancel. And we can look it up. We find that there's 3.79 liters in 1 gallon. At this point, again, this just becomes sort of an arithmetic problem as long as we've set everything up correctly. And this calculates to 6.87 times 10 to the minus 5th pounds per gallon. All right, let's move on to our next problem. These next 2 problems might not necessarily look like they're unit conversion questions, but we would approach them in almost the exact same way. Because what we're saying here is that the price of a gallon of gas is $2.39 per gallon. And we want to convert that to how much does it cost for 1 milliliter. Now, the first thing we should say here is, what do we expect as an answer? Do we expect a large number or a small number? Well, if you think about the relative sizes, a milliliter is tiny compared to a gallon. And so we should end up with a very small value for the cost of 1 milliliter of gas. So to get to milliliters, I'm going to first need to get to liters. And so 1 gallon is equivalent to 3.79 liters. And then we can go to milliliters. 1 liter is 1,000 milliliters. And we find that if the price of gas is $2.39 for a gallon, then to buy 1 milliliter of gas, it is going to be 6.31 times 10 to the minus 4th dollars per milliliter. Our next question is going to deal with a similar type of situation. We're looking at something again that we might not initially see this as a unit conversion question, but there is a lot of similarity here. So our car's gas tank holds 18.6 gallons. And it's 1/4 full. So we'll multiply this by 1/4. And so we know that currently we have 4.65 gallons. We also know that our car gets 16 miles per 1 gallon. So this will allow us to convert from a volume unit to a distance unit, something we might not normally be able to do. When we calculate that, we get 74.4 miles. And if we're going to account for significant figures correctly, then we would make this 74 miles. Now, normally we don't have to worry about unit conversions in terms of them impacting our significant figures. In this case, we do. And that's because the 16 miles per gallon is not an infinitely significant number. That's another measured value that we've only reported to two significant figures. And so in our answer, we are going to have to stay at two significant figures. Now, what the question's asking us is we see a sign saying next gas 73 miles. Will we make it? Well, I think we conclude that in theory we would make it, but probably not the best idea to risk it. All right, finally, our last one of these problems is going to take us back to this video.
Girlfriend boyfriend sing along night.
I'm sorry. I'm looking for a barber and I'm running out of time. My hair is growing at the rate of 4.6 yacht meters per femtosecond. If you're quiet, you can hear it.